Okay, today for our exponent unit, we're going to start to get into scientific notation a little bit. And I think we've talked about it a little bit before, but we're just going to kind of go into more depth with things. So I'm going to start on the C side, and as always, I recommend you start on the B side. Also, once you get down in here, I suggest doing it on separate paper or on the whiteboard. But as far as up here goes, we have two kinds of forms with this. We have decimal form, which you're used to, and we have scientific notation, and you have to be able to move back and forth seamlessly between the two. So for number one, we have 9.99 times 10 to the 6th, and that just means we need to move the decimal place 6 places to the right. This positive exponent means that the number is going to get way bigger. So that would be, let's see, 1, 2, 3, 4, 5, 6 places. And the answer is 9,990,000 because we moved the decimal 6 spots over. Looking at a smaller number like 2, we have 1.356 times 10 to the negative 3rd. So scientific notation also helps us write really, really small numbers. And that would be 0.001356 because it would move 3 places to the left since it is a very, very small number. And the rule with these is that this first number right here has to be in between 1 and 10. So you might get kind of a trick problem. This isn't on the worksheet, but it may show up on the worksheet, where you have like 27.6 times 10 to the 5th. And you may be tempted to think that that's scientific notation because it looks like it, but it's not, because this number right here is not in between 1 and 10. So you need to modify the decimal and then ask yourself, when I went from 27.6 to 2.76, did I make the number bigger or did I make it smaller? Well, here I made it bigger, so since I made that, or no, I'm sorry, here I made it smaller. So since this became smaller, I need to make this bigger to adjust for the decimal shift that we did there. Okay, on to the more complex. Let's go down to 19. So for 19, this is where a whiteboard is going to be extremely, extremely helpful. We have 9 times 10 to the negative 3rd times 8 times 10 to the negative 6th. So I think some of these showed up on quizzes a while back, and I may have made it around to explain it to a few of you guys. But we go 9 times 8, and then we have to go 10 to the negative 3rd times 10 to the negative 6. So just picture this in your head. This is like what we've been doing the last few days. So the base number of 10 is the same, which means we get to add the exponents. And that would give us times 10 to the negative 9th. So this is, here it is, it showed up. This is like my last problem. This 72 is no good. I need to make it 7.2 times 10. And then I ask myself, okay, 72 became smaller, so I have to make this bigger, and that's how you do the multiplication problems down towards the bottom of the page. Okay, for the division problems. So for the division problems, let's take, what should we do? Let's do 25. So this one is 3 times 10 to the 5th over 8 times 10 to the negative 2. So what you could do here is you could get this, and you could write it as that. And you could take this, and you could write it as that, and you could divide them in a calculator and you could get the answer. But I think a better way to do it is to apply our rules. So in a calculator, we would go 3 divided by 8, or in your head, I'm going to try to do it in my head. I think that's 0.375 times, and then we take our rules from the last couple days. When we're dividing exponents, we have to subtract, so 5 minus a minus 2 is 10 to the 7th. So again, this is not in between 1 and 10, so I need to make it between 1 and 10. And this time, since I had to make the number bigger, I need to make this smaller. And then I also noticed down here it says they need to be in decimal form. So that would give me, let's see, I need to move it 6 places to the right, so that is it. And the answer to this problem is 3,750,000. I recommend starting on B and moving towards C.